So this is Module 2, Foundations, which is about some basic ideas and assumptions that are relevant to this lecture series. And this is lesson 2.1, the scope of theoretical history. And some people may have a different take on what theoretical history means, so this is just the approach that we'll be taking in this course. And I want to begin with some general points. Then I'll talk about the timescale we'll be considering, and in connection with that I want to say something about big history as what we won't be doing, and then I want to say something about mythology and how it's relevant to theoretical history, and finally I'll talk about diversity, by which I mean gender and race, and how those issues are relevant to social evolution and theoretical historians. So, to begin with some general points, firstly, we will be taking the approach known by the annal historians as total history. So we'll be interested in anything that can help us understand the patterns of social evolution. So that means economics, geography, linguistics, political science, and so on. And if you're interested in everything, then theoretical history is a good thing to get into, because almost everything is within scope. Anything that humans do, anything that is part of society, is relevant to social evolution and historical change. And next, as we're dealing with history, we're going to be interested in time, and particularly change over time. And so some of the things that we might see are cyclical change, things that go up and down, evolutionary change, things that tend to develop in one direction and where there may be a sense of improvement through natural selection and progress. And lastly, we may be interested or may come across change that exhibits chaos. And with chaos, we get charts that look something like this. The system goes up and down, but it seems to be almost random. Even though there may be a definite rule guiding the behavior of the system, it looks very unpredictable. And the reason it's unpredictable is because systems with chaos exhibit what's known as sensitive dependence on initial conditions, which means that if you start off in just a slightly different place, at first it may seem to be following the same path, but very soon it deviates completely and there's no real resemblance. And because we can never be sure exactly what state we're currently in, there will always be some uncertainty. That uncertainty can lead to very different outcomes further downstream. So although in detail chaotic systems become unpredictable, if we look at these charts, they look much the same. They're jagged in the same sort of way. And so there are deeper properties of the evolution that we may study. So that the detail is unpredictable, but the overall properties of the system may be predictable. And we'll definitely be talking in much more detail about all these kinds of change when we come on to the mathematical section of the course. And now Fernand Braudel, who's one of the annal historians, and he wrote big books on centuries-long change in early modern Europe and the Mediterranean, said that time is one of three dimensions that theoretical historians need to be concerned with. So if we draw three dimensions here, time is one of them. And the second one, according to Brodel, is space. So the Mediterranean versus the South China Sea. These differences in space may have produced different historical forces and led to historical evolution in different directions. The third dimension, according to Brodel, is institutions. And by institutions, we mean things like the church, or banks and banking systems, or international treaties. NATO could be considered an institution. Or cultural movements like art movements, like Impressionism. These also influence social values and can influence social change. And beyond this, we also want to say we're interested in the whole Earth, the whole human race, all societies, back to the origins of human society. So it's not just documentary history, we're also interested in archaeology and early societies that didn't have writing. So to sum up, the approach we're going to take will be multidisciplinary. We'll be interested in these dimensions of Brodel: time, space, institutions. We'll be interested in the political, the economic, the socio-cultural sides of life, and we'll be interested in all societies back to the origins of human society.
Which raises the question of what we consider to be human society and when it began.
So, to begin with big history then. I mentioned that the Victorian sociologist Herbert Spencer, in Module 1 that is, that he was an early big historian. So he saw social evolution as an outgrowth of biological evolution, which in turn was an outgrowth of cosmic evolution. And this idea is taken up by many people today, and perhaps a leading big historian is David Christian with his book Maps of Time. Maps of Time. But there are many others. Let's just get that right. Maps of Time. But there are many others, and there's a website called something like bighistory.com, which has an awful lot of information about big history. It's a good place to start. Big historians divide this long process of cosmic evolution into a number of thresholds. I think there are 8 thresholds. I won't go through all of them, but let's just have a look at some of them to get the general idea. So let's draw a timeline, and this will be logarithmic. So we start back here at 10 billion years ago, then 100 million years ago, then 1 million years ago, then 10,000 years ago, then 100 years ago. And these are going down by a factor of 100 at each step. So big history thresholds. We start back here, the Big Bang. Then somewhere around about here, the emergence of galaxies, without which human civilization and human history could not exist. And then somewhere perhaps around about here, the emergence of life. Then going forward somewhat, somewhere around about here, the emergence of what big historians call collective learning. And that means the beginnings of human culture, so that it was no longer a case of what an individual learned in their own lifetime that is what they brought to their solving their problems, but what their peers, their friends and their family learned. And also learning could be passed down through the generations, so that at this point, instead of knowledge starting again with every generation, it could become cumulative, and so we could start to develop complex cultures and eventually civilizations. And then another big threshold is around about here, agriculture. And then somewhere around here we've got the modern world, the Industrial Revolution, the beginnings of the machine world. And big historians, as I say, see this as one seamless process of increasing complexity. And it's about recombination of existing elements, so that back in after the Big Bang, we had, subatomic particles, which then combined to form atoms, the atoms of the chemical elements, and those chemical elements could then combine to form molecules. Molecules could combine to form organisms. Organisms could combine to form societies, and in societies we generate technology, which is itself a recombination process. So new technologies are made out of existing technologies. We take the technology of the alarm clock and the technology of the electric kettle and put them together to make the automatic tea maker, for example. Now, the futurist Theodore Modis developed an alternative set of milestones for big history. That's Modis. And he has more of them, and they're more evenly spaced. And I've got them here, so let's put that up. Like so. So starting down the bottom, we've got the emergence of the Milky Way. He's got things like the first multicellular life, the first primates, the first stone tools, rock art, then the Renaissance, the invention of the transistor. So these are his historical milestones, big history milestones. And what people have pointed out is that if you take these milestones and plot them on a chart, and this is not a logarithmic scale, so from tens of billions of years ago to today, they seem to be massively accelerating in recent times. And we're looking at another kind of hyperbola. And in fact, what some people have done is actually shown that you can fit these points to a mathematical hyperbola, and they fit very closely. And the property of the hyperbola is that it shoots off to infinity at a particular time. And people have used this fitting of the hyperbola to the points to calculate that when that hyperbola will shoot off to infinity. And it's round about now, so according to some calculations, maybe as soon as 2026, or others calculate round about 2040. But certainly things seem to be heading to infinity sometime soon, and that's known as the singularity. A singularity is a point on a mathematical function where it goes to infinity, or where you have a divide by zero that leads to the function being undetermined, more strictly speaking. And people have suggested that this, divide by zero when it becomes undetermined, or the point of infinite growth, maybe when artificial intelligence takes over. So it's when human history comes to an end, it becomes irrelevant, and AI then continues on. And a book about this singularity, a recent book, is the 21st Century Singularity and Global Futures. And I contributed a chapter to this book, and I argued that this appearance of a singularity close to our time may be an artifact of our particular perspective. That, for example, Modis identifies one of his milestones as the invention of the transistor, along with things like the emergence of DNA, the genetic code. And I suggested that if you went back earlier in the 20th century, before the invention of transistor, people might have said, oh, well, the invention of the typewriter, say, is an important milestone, and they might have put that on their chart. So it would have seemed that things were taking off in their time. Or sometime in the future, people might say, well, the transistor, it wasn't really that big a step compared to something like the invention of DNA. So, but what was important was matter transportation. And so they would put that point on their chart, and it would seem that things were taking off in their time. So there is an issue about the subjectivity of the selection of these milestones. Now then, it's not completely subjective. There is some logic behind the selection of them, that they how much space they take up in encyclopedias, so to suggest that they're comparable steps, but there still may be some subjectivity in what gets covered in encyclopedias. And so some people have tried to develop more objective measures of increasing complexity through big history. And one suggestion is energy flow through a system per unit mass. So systems with a higher energy flow per unit mass would be considered more complex. So the human body, for example, there's a lot more going on in a small quantity of the human body compared to an interstellar gas cloud. So a human is more complex than an interstellar gas cloud. And then as society has evolved, for example, through agriculture, the amount of energy that society is using has increased, for example, through the energy of domestic animals. And then, of course, today with new technologies like oil and electricity, the turnover of energy of society per unit mass has massively increased, and that corresponds to the increasing complexity of society. Now, one of the editors of this book is Dave Lapoire, who's an American scientist, and let's get rid of that, an American scientist and theoretical historian. And he identifies a pattern in big history milestones which looks like this. So he identifies 3 key milestones. Here at 5 billion years ago, the appearance of life. Then at 5 million years ago, the emergence of humans, hominids anyway, and then 5,000 years ago, the emergence of civilization. And what he points out is that these go down by a factor of 1,000 at each step, and we could be leading here to the singularity. You see, these go down by 1,000 at each step, and he says that they can be, each phase can be subdivided into 6 subphases. 1, 2, 3, 4, 5, 6. 6 subphases. So, for example, on life, the first phase, the first biological organisms were simple bacteria, and then the next phase is characterized by the emergence of cells with a cell nucleus, and then multicellular organisms, and so on. He has other phases, and similarly has phases within that and within civilization. And what he shows is that these go down, there's an acceleration of a factor of 3 at each substage. And because there are 6 stages, you get 3 to the 6 for the overall multiplication factor, which equals roughly 1,000. So he sees this pattern. And Dave Lepois has also suggested that with respect to the singularity, that yes, we have this, in terms of complexity, this hyperbola, and we are somewhere around here where it's just about to take off to infinity. But he suggests what's actually going to happen is that this is then going to turn over and flatten off again. And he calls this a logistic hyperbola, or logistic hyperbolic curve. And so what we have is billions of years of not very much happening, and then the appearance of life and civilization and massive technological change. And here's the singularity that we're going through, or just about to go through. But then it's going to start slowing down, and then the universe will go into billions more years of no change again, or very little change. And as I've already said, then, we're not going to be taking this big history perspective. We're not going to be going back 5 billion years ago. We're only concerned with human history. And by that I mean true humans, so not Neanderthals, not Homo erectus, not these early hominids, but modern human behavior.
We're concerned with Homo sapiens sapiens.
And traditionally, modern human behavior has been thought to have emerged about 40,000 years ago, 40 kilo years ago. And that is by definition the beginning of the Upper Palaeolithic, the Upper Old Stone Age. But today some people say, well, actually we can see signs of modern human behavior perhaps back as far as 70,000 years ago, or even in some cases 200,000 years ago. And we're talking about things like cave art and making beads and using pigments to colour one's body, decorate one's body. But although there are these early signs, perhaps, they're kind of sporadic, but it is still about 40,000 years ago that we see not just new types of tools emerging, but perhaps more importantly, a change of pace. So that up to this time, social change was very slow. You could go hundreds of thousands of years with almost no change in the designs of stone tools. But from about 40,000 years ago, we start to see continuous change, continuous noticeable change that's just been accelerating ever since to our own day. And one suggestion as to what might have sparked this sudden change and change of pace is the emergence of the first general purpose languages. That's just a suggestion. You know, some people disagree with that, but some people suggest it may be associated with the emergence of the first general purpose languages, because by general purpose language we mean not just, you know, warning cries or you know, expressions of pain or something, but the ability to express complex ideas and say anything you want to say. At that point, you really could pass on complex experiences and complex ideas to other people and down through the generations. And that's perhaps what made possible this cumulative development of knowledge and culture from this point onwards, and led to this you know, upward movement that we can see. And language may be, it may not be language per se. Language could be just a special case of a more general capacity that developed then, which is the capacity for symbolic thought. That is, to give meaning to symbols. So with language we give meanings to sounds, but with sign language we can give meaning to hand movements, or in a dance we can give meaning to movements of the body, or today with coins, you know, we can give meaning to a metal disc. That piece of metal symbolizes complex economic relationships, for example. So, or, you know, if you go to a job interview and you wear a suit and tie, your clothing is giving out a message. It's a symbol. It's giving the message, you know, that you take this occasion seriously and you're someone who will fit in. So that is one theory, but then it may be actually that we've already seen a number of examples of hyperbolas in social evolution. We saw the demographic hyperbola talked about in module 1, and here we've been talking about the hyperbolas and the singularity of big history. And we will see later on that the hyperbolas are indeed common in theoretical history. So it may be, well, with hyperbolas we see that they turn a corner. This is a part of the property. Very little happens and then they turn a corner and then they seem to shoot upwards. So you know, when we talk about the Upper Paleolithic here, we see a change of pace. Well, it may not be that anything particular happened there at all. It was just a slow change of a hyperbola, and then it's about that point that our eye can start to detect an upward movement, and it seems to turn a corner from our perspective. Because what is known is that this change of pace, the emergence of modern human behaviour, if that's what it was around 40,000 years ago, did not correspond to a biological event. The physiology of humans was the same back here as afterwards. So this was a cultural phenomenon, if anything. But as I say, it may just be an artifact of the fact that it's a hyperbolic growth, and we seem to see a turning of the corner at that point from our perspective. But it's not really important from this point, from this course, you know, precisely what makes a difference. It's just for us to draw some kind of line under what we're doing. So, you know, we go back so far but not further. And for a round number, I tend to put it at 50,000 years ago. So this is a kind of, we'll be looking back at archaeology back to then, the Upper Paleolithic, but we won't be going back into Neanderthal stone tool making and what Neanderthals were up to, that kind of thing. But it, you know, it's not going to be an important issue for things we're talking about. We're not going to sort of start saying, oh well, we won't talk about that because it's 50,000 years ago. It's just to give us a mental picture of the kind of scope that we have in mind. And when we talk about this change of pace, this emergence of modern human behaviour around this kind of time frame, I would say it's a global phenomenon. It affected the whole human race. It's not something that emerged in a particular place. I would argue that humans back in those days were an entirely connected species, and what happened in one place soon propagated, quickly enough so that we don't really notice it to the rest of humanity. Now, a lot of people would disagree with that and see people back in those very remote times as disconnected from each other in different parts of the world because, they could only move around on foot. But the more time goes on, the more archaeologists you hear saying, oh, well, people were more in contact and trade occurred over greater distances than previously thought. So as time goes on, I think that view that people were very connected in the past and have become more fragmented over time as the world has filled up, that point of view is becoming more acceptable, not less, with archaeological discoveries. And again, this is something that we will be talking about when we come on to issues of social evolution later in the course. But the point is that this horizon is something that applies to the whole human species, not just to a subpopulation of it. Okay, so that's all I want to say about big history and then the timescale that we'll be adopting, 50,000 years rather than 15 billion. So hopefully that will make our task a little easier. And then I said I would talk about a few other topics, things that are important to theoretical history, but that we won't actually cover in this course. And the first one said would be myth. And you might say, well, why should theoretical historians be interested in myth? Isn't myth just silly stories, made up stories? They're not really tell us anything. Well, maybe not. The fringe archaeologist Stan Gooch said that when archaeologists discover a pot in the ground, they don't ignore it just because it's broken and there's only a piece of it left. And when medieval historians discover an ancient manuscript, they don't ignore it just because it's tattered and torn. So why should we ignore myths, which are just distorted and fragmentary remembrances of things that really happened? So what he's saying is that we should take myths seriously and try to extract understanding from them the same way we can extract understanding from a piece of broken pot or a single tooth or part of an ancient manuscript. Well, maybe there is historical information to be gleaned from myths if we treat them in the right way. But even if the content of myths itself is not of interest, what we can learn from myths is if two populations, two social groups have similar myths, that tells us that maybe they were connected in the past or have a common ancestor. And that in turn can then tell us about how people moved around the world and how they migrated to different environments and how the world came to be peopled the way it is today. And another thing that we can learn from myths is what people were paying attention to, what was important to them, and what they knew. So the great scholar of myths, Joseph Campbell, distinguishes between the kinds of myths told by hunter-gatherers, people who live on wild foods and who hunt for their living, and agriculturalists, people who farm the fields. So in his book about the different types of myth, he called the one the way of the animal powers, and the other the way of the seeded earth. And the idea being that the hunter-gatherers thought about the world in different ways from agriculturalists. And so if we can see the content of the myths, we can see something about people's way of life. And also we know that myths talk about Mars and Venus and Jupiter, the gods, but they're also planets. So maybe these myths actually encode cosmological knowledge, people's understanding of astronomy, and some of the stories about how the gods behaved are actually allegories for the movements of the stars and planets. So studying myths can again tell us about the evolution of human knowledge in these areas. So for these and other reasons, myth is potentially a goldmine for theoretical historians. And in this course and in my book, I've neglected it because I kind of had to make some decisions as to what to put in and what to leave out. But in future editions of the book, I certainly hope to come back to myth and the work that has been done on myth in more detail, and in perhaps a future iteration of this lecture course. And then the last thing I said I'd talk about is diversity. So by diversity we mean race and gender. And just to give you sort of a couple of ideas to start off with, a feminist historian wrote a paper called "Did Women Have a Renaissance?" So we can talk about the Renaissance and, you know, a sudden growth of new learning, but did women experience that period in that way? And someone else has pointed out that, say, in American or Anglo-American generations, we talk about the baby boomers, the boomers. But does that term apply to Black Americans? Did Black Americans have a baby boom, and did they go through the same experiences as white American baby boomers? So these points make us think about the fact that we might be developing theories of history, but is our understanding of history perhaps based on a particular gender and racial perspective? Clearly that is something that theoretical historians need to think about. And I'm discussing it here to say that yes, it's something we need to think about, but it's not something that we will be addressing in this lecture series. So it's something for the future. Theoretical historians actually haven't done very much on this yet, but we can certainly expect it to become more of an issue in the future as theoretical history starts to find its feet. And I'd like to just say a few more words about those two issues of gender, firstly. So humans are sexually dimorphic. So females look like that, and males look like that. Males have broad shoulders, females have broad hips, and males tend to be taller, stronger. Females can bear children and nurture children, lactate. And these physiological differences, can be expected to have influenced social roles, and certainly at first sight seem to have influenced the social roles. But of course, one thing about being humans is that we can overcome the biological necessities with social conventions, and so we shouldn't see biology as determining the way men and women have interacted in society. It may have been an influence, but the social and cultural ideas have also shaped that. And technology, so let's put that here, social norms, possibly to some extent independent of these biological differences, and technology also changes this. So in the past, men's greater muscular strength may have been important in the kinds of roles they took on in society, but now when we do so much online and it's all just interacting behind a keyboard and a screen, physical strength isn't really so relevant. So those role differences and gender differences may be being eroded. But we also need to acknowledge that women have played an enormous role in history. So as we're talking about history, women are certainly a huge part of it. We know that there are individual famous women who have made great contributions to history. people like Cleopatra and Joan of Arc and Florence Nightingale, who was the founder of modern nursing, Marie Curie, the physicist who won 2 Nobel Prizes. So, women have made major historical contributions. And also women collectively have contributed to social change. Back in Roman times, women could get together and protest against laws that they didn't agree with and have those laws changed. And of course the same more recently, hundreds or so years ago, women demanding the vote and eventually getting the vote. So women's pressure and desires have certainly shaped the evolution of society in those respects. And women also play perhaps a particular structural role in society. Anthropologists point out that women often mediate what's known as cross-cutting ties. So a woman has a husband and she also has a father, and these may belong to different groups, certainly in societies where it's the norm to marry out, exogamous societies. Not all societies are exogamous, but in exogamous societies, women bring together 2 separate groups, and of course they, because they have loyalties to both, they can keep the peace between those groups, and so they have long served an important role in that kind of mediation. And also we see this, in the sort of documentary history of Europe, dynastic marriages. A princess would marry a prince, and so would bring together 2 royal families and bring together 2 peoples, 2 countries. And their role wasn't necessarily just passive. I mean, looking through English history, we can see queens like Eleanor of Aquitaine, who were very proactive in shaping the political events of their day. Another aspect of women's structural importance to history is their role in education. So they tend to introduce young children to the norms of their own culture, and then they can also play a role in higher education. I mean, back in Victorian times, many children were educated in so-called dame schools that were run by women, and we definitely see today the important role for women in education. So while women have played such an important role in history and a certain central, here in theoretical history we're not going to talk about women per se, because we're really interested in societies and not characters. But so even though we may not be mentioning women, they are certainly part of the things we're talking about. If we plot that again, that population hyperbola, world population against time, this is a graph of world population, and of course women are part of world population, and indeed they make a special contribution to world population because they give birth to it. So we may not be mentioning women, but certainly women are part of what we're talking about. But that all said, the existence of 2 sexes in society may be, is very likely to be an important consideration in how society has evolved, and therefore in the kinds of things we're interested in theoretical history. For one thing, because men and women have kind of different outlooks on life and different interests, in different goals and ambitions, there is a kind of a tension between the 2 sexes of they depend on each other, but they're also to some extent in conflict, and so it's an interesting topic for theoretical history as to how that tension, that dependency and conflict, has helped to drive social change in particular directions, or maybe hold it back. So certainly this whole issue of gender is a future direction for theoretical history, even if we don't address it explicitly in this course. And the last thing I sort of talk about under this issue of diversity is the whole thing of race. So there are physiological differences between human populations. Those may be related to biological and environmental factors. One well-known idea is that melanin, the compound that makes skin darker, helps to protect against the sun's ultraviolet radiation, and so helps to prevent skin cancer. But it also inhibits the body's ability to make vitamin D, which is an important nutrient. So that in more northerly latitudes where the sun's rays are weaker and therefore protection against solar radiation is less important, but the ability to make vitamin D from the sun's weaker rays is more important, people will have less melanin. So we see fairer skin populations the further north we go. But that, may not be, although that's a sort of well-known idea, it, is not necessarily absolutely true. It may be more complex than that. One thing we noticed that Eskimos, who obviously live very far north, are not so fair-skinned, and maybe their skin colour is not so different from what we see in equatorial Americas, which according to that theory should be darker, more like those in equatorial Africa and India.
Migration has also disrupted links between the environment and racial characteristics.
But there are nevertheless certain biological rules that people have identified about how climate affects physiology. There's Allen's rule, for example, which says that organisms that live in hotter climates tend to be taller and thinner, because that helps them shed heat more easily. And conversely, organisms that live in colder climes tend to be shorter and more compact. And there's Bergman's rule, which is a similar point, that in colder environments animals tend to be heavier, they keep more body weight, keep themselves warm. And then there's Gloger's rule, which says that populations that live in warm and humid environments tend to be more heavily pigmented than populations that live not in those environments. And this is something that can be seen in birds, in mammals, and also in humans. So there do seem to be biological factors that create racial differences between the populations of a species. But on the other hand, there could be cultural factors involved. Some people suggest it may be related to assortative mixing, which refers to the idea that people tend to associate with and mate with people who are more like themselves. So if assortative mixing is the case, it would imply that fairer skinned people tend to mate with fairer skinned people, darker skinned people tend to mate with darker skinned people. And if that were the case, then it would help perpetuate the existence of a fairer skinned population versus a darker skinned population. But whatever the reasons behind racial differences, they are something that people are very sensitive to and aware of. Now, throughout my life, I've known parents saying about their children, being proud of their children, not noticing racial differences, suggesting that they're not sensitive to this, and that therefore it may be something that is perhaps not innate, but that we learn culturally. I don't know. I had an epiphany a couple of decades to 20 or 30 years ago when I was in a supermarket, and I was standing at the checkout, and I could look down the line of cashiers, and because of the way I was standing, all their faces were kind of arranged in a line, and I could just see one behind the other, and they were all different colours of white, brown, black. And what struck me was, oh, these faces aren't different colours. They're just different shades of one basic colour, which is kind of tan. And I saw that because in this view, there was a riot of colours, all that advertising and what people were wearing and the uniforms of the staff. So there was blues and greens and oranges and pinks and yellows. Those are different colours, but this line of faces was just stood out as one single colour in this riot of colours, and just different shades of this tan. And I wanted to take a picture of it because to describe it perhaps doesn't really bring home how it really looked, but it was very striking, this. But unfortunately, I didn't have a camera with me at the time, and when I thought about doing it, not so long afterwards, the supermarket redesigned the shop so that the cashiers were back to back, and so you didn't get that same kind of one face behind the other effect. But nevertheless, although if we saw different shades of blue and a lighter blue and a darker blue, we still say, oh, well, it's just blue. We wouldn't get uptight about it. But somehow we are very sensitive to these variations in the shade of human complexions, and that has social effects. Obviously, we know that there's been, for example, discrimination against racial groups, not just based on skin colour, but based on other factors as well. But there is discrimination against different races, the kind of thing we've seen in South Africa or even the United States in quite recent times, of laws specifically discriminating against certain racial groups. And today people remain very sensitive to it, and it's affecting the way people try to structure society, not this time in the name of oppression, but in the interests of creating greater equality between groups. But certainly race is still very much, as we all know, on people's minds as a factor in social behaviour. And theoretical historians in the past took an interest in the whole idea of race. They classified the different races of humanity, and they developed theories based on that, theories perhaps explaining the different outcomes of different societies in terms of race, or using racial comparisons to suggest how populations were related to each other and how they might have moved around in the past. So these were racist theories, and I don't mean that in a kind of as an insult, but in a technical term. These were theories that used race as an explanatory factor. So in that sense, they were racist. But the theoretical historian Pareto, 19th century, said that race is not relevant to theoretical history. And as theoretical historians, that's something we want to believe, that race isn't going to be relevant to the things we're talking about, because if we're comparing, an empire of these people over here with an empire of that over there, and try and draw conclusions from that to our own situation, we want to believe that the raw material in each case was very much the same, because otherwise, we're not comparing like with like, and how can we draw any conclusions about this population that are relevant to a racially different population and to our own time? If in science the laws of physics changed from country to country and changed over time, it would be very difficult to come up with any sensible theories and laws. So you want to believe that the situations are comparable, and that in our case for theoretical history, that people have been much the same at all times and in all places. That's what allows us to compare them and find general laws in the patterns that we see. Now, that may not be true, but it's something we want to assume. But maybe personally I'm becoming less convinced that it's true in an absolute sense. I don't know, but I'm not trying to draw any particular conclusions or make any particular points about this, just really to highlight this as an issue and some of the issues that it raises for theoretical history. And it's certainly something that the theoretical historians need to address in future, and hopefully will become a part of theoretical history. But at the moment there isn't very much about it, and so we in this introduction where we're just kind of starting out, we're not going to get into it explicitly.